Hello everyone, welcome back to my channel. I hope you guys are doing amazing. So in today's daily challenge of Leetcode, I will show you two methods to solve this problem. One of them is pretty obvious and straightforward, and the next one is interesting. And one of them will obviously give a TLE. And I hope you are also following my DP playlist where I am teaching DP from very basics to advanced. And no matter where are you in your learning path, it will be definitely helpful. And for your placements also it will be really helpful, as I will also go to advanced topics like digit DP and bitmask DP. Okay, so keep following my playlist as I will be doing everything. So let's see today's problem. Sum of k mirror numbers. You are given a definition of a k mirror number, which is a positive integer without leading zeros that reads the same as forward and backward. So which is a palindrome in base 10 as well as base k. And you are given k and n. Return the sum of the n smallest k mirror numbers. So you need to find the smallest k mirror numbers, n smallest k mirror numbers, and you need to sum them all. You need to sum them all. That will be in the answer of long. So you can see that n and k is 30, but the thing is that you can barely visualize anything from this n and k, because even if n is equal to 30, you see the answer goes till long, right? So it is possible that in the final sum, so you see the sum is calculated in this manner by summing 1 2 4 8 21 21 here and so on till 212. Since the final answer is in terms of long, you can think that a term may be also of long, and definitely you cannot iterate through a brute force method, so that will give a TLE. Okay, so let's try to think how much can you optimize it. So you can try the best. You can try your best to optimize it. Okay, and we also will also use a very standard way of generating palindromes, which will also be helpful in many other problems. So definitely stay till the end of the video, and let's try to see the approach. Okay, so what can you do your best? What can you do your best? So let's say you are given k and n, right? So if you want to do a complete brute force, what will you do? You will start from a 1. You will start from 1 2 3. You will go on checking. Okay, and you will keep an answer. You will keep an answer, and you will say that you will also keep a variable count. Okay, count you initialize to 0. So and you will say that while count is less than n. So while I have got this n k mirror numbers, I will keep checking each and every number. So maybe you will have another number initialized to 1. So you will just check that is this num k mirror. Let's say you have a function which checks whether it is a k mirror or not. So you will just check that is this number a k mirror number, and if it is, then you add plus equals to answer, add plus equals to the number. And what you can do is, if it is a k mirror number, you just answer plus equals to, and you just num plus plus. Okay, you just do num plus plus, and now you see this num, you might be adding a very long number, long ll number also to this answer. So it might not be feasible to do every time this incrementation, which might result in a TLE. Okay, so we will do our best to shorten it. We will do our best to shorten it. It was shown that for it, like, if you just check it, for k equals to 7 and n equals to 30, you are getting the worst case of 10 to the power 10. Okay, you will getting a number which is 10 to the power 10. So you cannot verify this actually. So I verified this using a computer, but you cannot really verify this. So what you can do is that you can try to optimize it to something more optimal. So what you can do, okay, I will show you a very generic method of generating only palindromes. So we are bothered with checking only palindromes, right? Okay, so this first of all, this k mirror number, we can visualize that you can easily do it in log n, right? You can easily do it in log n, because you need to traverse to the digits of the number to check if it is a palindrome, and then you convert that to base k also. So if you don't know how to convert to base k, so if you have a number, let's say 11, and you want to convert that to base 2, so what you do is that you divide by 2 and you get a 5, and then remainder is 1. Then you again divide by 2, you get a 4. uh, you get a 4, and you again the remainder is 1, and if you divide by this 2 again, you get nothing but this 1 and a 0 remainder. So you take everything from this back and you get a number which is 1011 in the base 2. So if I ask you how will you convert a number n to base k, so what will you do? What will you do if you are asked to generate a number in base k? So you will take this number n and keep dividing it by k. Okay, you will keep writing the divisor here and the remainder here, the first remainder. Okay, and again let's say you will again write this k here and again divisor 2 here, remainder 2 here, and unless and until this divisor turns to something less than k. Okay, this thing, let's say this divisor, let's say dx and rx, it turns to something less than k, you will just keep on doing it and you will just keep on writing the number which will be like n equals to dx dot r2 r1 base k. Okay, so that's how you convert from base to this. Okay, now since you are only bothered about palindrome, you can write from r1 to dx also. Okay, both are, if this is a palindrome, the reverse will also be a palindrome, so it doesn't matter. Just I'm telling you for this hint. Okay, just no need to bother about it that much. So what you will do, what you should do, so you see, I will try to propose a method which generates only palindrome. Okay, method generate all the possible palindromes by enumeration. So what you do in this case is very simple. You start with a number n, and also you keep a track of this number by this p also, right? You initially set this n and p both to 1. Okay. So what you do, you try to generate palindromes by copying numbers. So what you can do, if you have a number, let's say 63623, you want to generate the palindrome from here. What you can do, you can reverse this number. What will happen if you reverse the number? Reverse number will be something like 326 and write it just concatenate it. Okay, so if you reverse the number and concatenate it, you will get 623326. Okay, and if you, what you do is that if you reverse it but you keep the last number unrepeated, 62326. So this is a standard method to generate all possible palindromes. Okay, you are doing nothing but generating an odd palindrome here, odd length palindrome, and you are generating an even length palindrome. Okay, every time the odd length palindrome you are generating will be smaller. So you should generate that first, because you need to generate in order. Okay, you need to generate palindrome in order, right? So this is important. As you need to generate in order, it is optimal to generate the odd length palindrome first. Okay, so how will this exactly work? If I try to show you now, it will be very simple for you. Why I am telling very simple? As I told you that how you will already generate. So let's say the first number for n equals to 1. Okay, p equals to 1 also. You are having this n is nothing but a number. Okay, so not this n30. This is a number num, which is 1, and this is sort of previous. It is tracking the previous value. So you will keep incrementing num. You will just keep incrementing num. Okay, unless the num has one extra digit. So that is num goes from that n digit number to let's say n plus 1 digit number. You will keep iterating num. So as you can see, you will go from 1 to 2. Okay, 2 to 3, 3 to 4, and you will go to 9 also, till 9. So you will start with 1 and go till 9, and what you will do is that is very simple, is that as I told you, you can generate even length and odd length. Like you first need to generate the odd length palindrome. So what will happen if you try to generate odd length? You will take a number, let's say 3. You will reverse it. What will be? It will be 3. And before concatenating, you will delete one occurrence of the middle number. The middle number is their single number only. So you will get 3. If you want to generate an even length palindrome, you just take 3, you reverse it and just concatenate to get 33. Okay. So the thing is that first you generate all the odd length palindromes. So the palindromes which will be generated in order will be 1, 2, 3, 4 goes till 9, and then it will try to generate odd length starting from this one. So it will be nothing but 11, then it will be nothing but 22, then it will be nothing but 33, and till 99. Okay, so you see, n has now gone from 1 to n equals to 1 to n equals to 10. Whenever it sees that n has got to 10, okay, it will, this previous value, the p which I used here, this will help me to reset my count, reset my value. Okay, this p will help me to reset this n. Okay, so this n will be resetted to 1, because now I need to, after generating the odd length, till here it was the odd length, and this is even length. So after generating the odd length, I need to reset it the n. Okay, because I need to duplicate the things now. I need to duplicate 1 1, and then n, as n goes to 2, I will duplicate this 2 2, and n goes to 3 until n will again go till 9 here. Okay, so it will go till 9 here. Now what you need to do is that, and now n will be 10. Okay, now n will be 10. So what will happen now? What will be the next palindrome? You start generating from 10. You see how to generate the odd one. You just revise the number. It will be 0 1, and you duplicate and you try to remove this 0. Okay, so how will it be? It will be 101. Okay, it's very simple, very easy. I hope you understood it. For n equals to 1, you got it. Now n will be, n equals to 10. Now n will be 11 naturally. So from 11, how can you generate? It will be 111. N will be now 12. How you can generate? 121. And similarly, you can just go until n equals to 19. You will generate 191. Okay, when n will become 20, you do not need to reset n, because as I told you, reset n only when, only when reset n only when the number of digits of n is increasing. Has the number of digits of n increased yet? No, it's still 20. So still you can generate palindromes, right? Still you can generate palindromes like 202. Okay, from till, you can just go till 99 and generate palindromes 999. Okay, after you reach this 1000, after you reach this 100, okay, you need to reset to n equals to 1, n equals to 10. You need to reset to n equals to 10. Now previous will have the value of 10. After the first iteration, previous will have the value of 10, and you need to reset this value of n to 10. Why you will reset? Because now you need to generate the even length palindrome. So far you did with the odd length, and okay, these were the odd length palindrome. Now from n equals to 10, you will get an even length palindrome, which is 1001. You just reverse and add. Okay, now from n equals to 11, you will get this. Okay, now from n equals to 12, you will get this. And same way till n equals to 99, you will go on, and the same thing you will keep continuing to get the palindromes. You will get the palindromes. Okay, so you, if you go to 100 now, you generate something odd. If you try to generate odd, it will be something like this. Okay, you will get this number. So I hope you have already clearly understood. So if you have not understood, definitely ask me in the comment. But I guess it is very clear, right? It is very clear of how to generate the palindrome. I think I have made it very clear. How will you generate the palindrome in order, in particular order you will generate. So once you have this generation, do you think anything is left in this problem? It becomes very simple, right? You just take the palindromes. You don't even have to check whether it is a palindrome now. So you just take this n, which is a palindrome, in base n. Okay, so in base 10, it is a palindrome. You convert that to base k using the method which I told you. Just divide k and take the remainder. So you can just do module k and by equals to k. You can easily understand that, right? So you will get all the numbers. As you get all the numbers, all these numbers, you can just append it to a string. You can just append all those numbers to a string and check if it is a palindrome. You just return that true, it is a k mirror number. True, it is a k mirror number. So you see, it becomes very simple and very easy once you get to understand this method of generating palindromes. Okay, so this method is used in many problems, not just this problem. Okay, this is a very useful method of generating palindromes. So let us try to code this problem out. There is not much difficulty in the coding. I will just directly use a long answer. As I told you, I will use a num value which is initialized to 1. I'll also have a prev value which is initialized to 1. Okay, so what I need to do now? I need to see for both the odd length and even length also, right? So I just do a count in CNT. I initialize that to 0, and I will just do while CNT is less than n to do something. Okay, you just do something. Now, one thing you need to do, that this reverse, these things of reverse, you need to do for every integer, right? For every integer, first the odd case and the even case. So let's say I will use a loop. Instead of writing the same code 2 times, I'm using a loop of length 2. Okay, so what it will say that if, so go from x 0 to 1. Okay, here it will denote nothing but if x is 0, it means that generate odd length palindrome, and if x is 1, generate even length. Okay, even palindrome. Okay, so if x is 0, you generate odd length palindrome. In x is even, you generate even length palindrome. So if you try to bring two strings, if you try to convert them into strings for easier manipulations, so you will end up in converting string to num, and you just copy this string s2 in some other string s1 also. Okay, and what you do is you can do an s2 dot popback, s2 dot popback, and reverse. So what I'm doing, I will just explain you. Bear with me. Dot begin, as the same thing I'm doing as I explained, already explained to you. So what you see, what did I do here? I am taking one number, converting it into string. Okay, so for generating an odd and even length, what can I use? What can I use exactly? So if you see, uh, for generating an odd length, if I have a number, as I told you, 623, I will convert that into string. So my s1 is having 623, my s2 is having nothing but I will just copy the string. See, I have copied the string, so s2 initially has 623, and then I deleted the last element of this by using pop back. I deleted the last element, so it means that I deleted 3. My s2 is now having 62. Now I reverse this string, so it means that my s2 is now having 26. Okay, so you can understand, if I do just s1 plus s2, now that will give me 62326. That is nothing but a odd length palindrome. Okay, that is nothing but the odd length palindrome. I hope you understood this. And what if I need to generate the even length palindrome? I will do nothing but s2, okay, s1, and s1 of s1 dot size minus 1. What does this mean? I will take this number and s2. What does this mean? s1 is nothing but 623. S2 dot last number is nothing but 3, and then S2 is nothing but 26. So if you see here in this way, if I do it, I will end up in generating a 623 326. I will end up in generating an even length palindrome, which I need to generate later. But this S1 and S2 I will use always. So just to shorten my code, I just did this. Now if I have x equal to 0, I will generate an odd length palindrome. Okay, so let me generate it. S1 plus S2 is nothing but my odd length palindrome. And else, if I have x equal to 1, I will generate an even length palindrome. That is nothing but S1 plus S1. You see, S1 dot size. I am taking out the last number, and S2. Okay, so this is very simple. I just generated an odd and even length palindrome. So now I need to check. What I need to check is very simple. I need to check for all the numbers. If is kpal, okay, I will write a function kpal. Is kpal of this odd? If it's true, I will also pass k to it. Then you add answer plus equals to a string to ll. Okay, I will just do string to ll. It converts the string number to long. Similarly, there is a string to integer also, stoi. So I will just add this to odd. Okay. What I will do, I will add the count also, as I have increased my count, and I will also have uh, the number incremented. I will also have the number incremented. That I will do at last. No problem with that. Okay, and the similar same thing I will do it with even length also. The same thing I will do it with even length also. Okay, just make the changes for the even length. Now you need to check that how many times do I need to iterate this whole code. This whole code, how many times do I need to iterate? So you see, as I told you, as long as n does not increment its digit. So as I told you, n should not have incremented its digit. So from, you see, as I already told you, n should not have incremented its digit. Only that time I will do it. So what is the number of times that I need to iterate it? What is the number of times that I need to iterate it? If you try to see, so if I have a number n, let's say 62, I want to iterate it till it does not become 620. So what is that number? How many iterations will I take? How many iterations will I take to reach from this to this? This is nothing but 10 into n. This is nothing but n. How many iterations will I take? 10n minus n. So it's very simple, okay? Similarly, from 1, I will go to 10. I will need 9 iterations because 10 minus 9. Okay, so that's 10n minus n. Okay. So that's very simple. I will now have the number of iterations. So I'll give a tab here. I will have the number of iterations int it as nothing but 10 into num minus num. I will have this number of iterations, and I will just do while it minus 1. Okay, and also count should be less than n because here count is also increasing, right? In each iteration count is increasing. So we need to take care of that also. So you just see I have done nothing. I've done nothing. I've just done that while let me put this first and it minus minus. Okay. So while count is less than n and it minus minus, you just keep finding this odd length and even length palindromes, and you just keep checking these palindromes. If it is valid, add in the answer. Add in the answer every time, and uh, you add this number, you increment this number num plus plus. Okay, for every loop you just increment this number, you just add num plus plus. Okay, uh, and what you do after you have done, if x is equals to 0, what you do is that after getting I mean, you need to reset the num to previous also. As I already explained you in your explanation, you need to reset the num to previous. So uh, after finishing with odd case, reset num to start with even case. Okay, so you start with even cases, you need to reset num. So what you do here is very simple. You just reset the num to previous, and what if it's after finishing with the even case, you need to take the previous also, right? You need to generate the previous to num. So what did I do here? So you see, I was first of all I was generating all the odd numbers. So with n equals to 1 and prev equals to 1, I was generating all the odd numbers I generated, right? And then I reset n to 1. Okay, so n to previous, I just reset it and generate all the even numbers now. Now I have n equals to 10, but I need the previous also to be 10, right? Because I will now start with n 11 12, and I will go till 99, and then again I need to reset n to 10 for generating the even case there also, right? So I need to just reset n equals to prev. Okay, prev equals to n. Sorry. I need to reset prev equals to n here also. So that's why I'm doing. So I am doing prev equals to n. So after all this, the thing which remains is very simple. I just see out answer. Okay, I will just see out answer. That's all. I will just return answer. I need to write this function is kpal. That is a very easy one. You can do it easily, right? So bool is a palindrome. How I will check it? Uh, I have a string num with me, and let's say an str with me, and I have k also, right? In k. So what I do is very simple. I first convert this to an integer, not to integer, it may be long also, as I told you, right? So it may be long. So I just convert it into a long num, which is nothing but stoll str. So now while num, what I do is very simple. I just convert to k num. Okay, I will just convert to k num. This is the base k. I'm just converting into base k. I'm keeping it as a string because all I need to check there is whether it is a palindrome or not. So I'm just keeping it as a string. And what I'm doing is very simple. I just do num divide equals to k. As I told you already, I just am doing divide equals to k. And I need to add the remainder to this number. That's how we convert to base k. So I just add the remainder. So num module k is what I will add to this k num. So k num will be plus equals to string. Just convert this to string. Don't forget to do that. And this, okay, while num is greater than 0, you will just keep on doing it. And you will get this k base number easily. This is a very simple method. Okay, don't need to worry about it that much. So now you go from I to k to num to size -1, right? So you just go and check all the numbers, and you just check that if this k num of I is not equals to, if anywhere it's not equals to k num of I n minus I, k num of k num dot size uh okay -1 minus I, just return false because it is not a palindrome, and otherwise by default you return true. I hope you easily understood this. Is this loop just checks whether it is a palindrome. So it checks from the backward letter, and this is the front letter, so checks whether palindrome. And I hope you already know this, already know how to check a palindrome. This everyone knows. And this converts to base k, converts to base k. Okay. And that's all. That's all, I guess. That's all, and that's very simple. Okay. If you know to generate this palindrome, this becomes a very simple problem. Let's try to run it and check if it works. Or we do have some error which we need to correct. We are getting a TLE. Okay. So that should not happen according to our. There is a very big mistake here. If this thing should be inside the while loop, right? Because every time I'm doing this, and that's why I have done the while loop, because I don't need to repeat this again and again. So what happens is, there for every as I'm incrementing num inside the while loop, so I just need to convert that to string every time, and that again. Okay, so as I'm incrementing num, so it is go from 10 to 11 or 11 to 12. I just need to convert it immediately, right? So when it goes from 11 to 12, I will get the odd length palindrome as 121, and then it goes to 13, I will get 131. So I need to let's try to submit it and check if it works. So yeah, we have the accepted thing. Now, if you might think that why is the runtime complexity so bad? Why it's 7% only? So you see, it's not that bad. It's first just do this. If you want to get 100% bits, you just have to copy paste that code. I mean, I don't know how they just write it in the list in this way. It makes just no sense. So that's all. That's all for this video, I guess. This was the only method which just came to my mind that works. The brute force definitely gives a TLE. So yeah, that's all. That's all for this video. This was a hard kind of problem, but I hope your day is going to be really easy. Thank you so much.